Good morning, all of you. I, Dr. Badri Mohapatra, Assistant Professor, Instrumentation Engineering Department, AISMS IOIT. Today we will be discuss on control system, and under control system we will be study of different poles and zero of a system, then transfer function of a Laplace function, then we'll be go for some examples of transfer function. So introduction to pole zero system. So first of all, we have to know what is the definition of poles zero or eigenvalue in a system. So particularly poles, it can be defined as roots of the denominator polynomial, values that transfer function magnitude to go to the infinite. Similarly, zeros, that is the roots of the numerator polynomial values that cause the transfer function to go to zero. So here we can look at here one example will be there where g of s is equal to s plus z1 multiply with s plus z2 plus dot 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 s plus zn divided by s plus p1 s plus p2 plus s plus p3. So here we can say that any system can be having some numerator and denominator value. So basically the denominator value which will be represented as poles and numerator value which will be represents as zero. So generally the transfer function which will be defined like as I told that this will be termed as a poles and this will be termed as a zeros, and there will be some k is nothing that is gain of the system. And here you can look at here z1 z2 which will be represent all the zero, and p1 p2 are all the poles. So number of poles all the time it will be greater than number of zeros. So it will be depending on that system, what type of system which will be useful. So depending on that, the poles and zero will be defined from that gain of the system. So how to define this poles and zero? So basically, particularly here we are considering one example like pole zero map. Here you can look at here g of s is equal to s minus 2, s plus 2 plus j4, then in bracket s plus 2 minus j4 divided by s minus 3, s minus 4, s minus 5, s plus 1 plus j5 and s plus 1 minus j5. So if you will be look at, so this all values will be poles. So poles will be 3. So s equal to 3, then s equal to 4, then s equal to 5, then s equal to minus 1 plus j5, then s equal to minus 1 plus j5. So if we'll be considering as zeros, then we will be say that s equal to 2, then s equal to minus 2 minus j4, s equal to minus 2 plus j4. So when we have to represent all the poles and zero in the plane or in the S plane, then we have to be represent like cross symbol which will be represented as poles, circle symbol which will be represented as poles. So cross means it will be represented as poles and circle means it will be zero. So zero in the sense here you can look at it s equal to 2. So if you will be look at in this axis, so 2 we have to put one circle. But s equal to 3, s equal to 4, s equal to 5, we have to put cross, cross and cross. Then if you look at it, the 0, minus 2 plus minus j4. So here you can look at it, this is a circle. So circle all the time represent as zeros and poles all the time represent as a cross. Next, transfer function of a system. So basically one have to know what is transfer function. So basic definition is that it is a ratio of Laplace transform of output signal to Laplace transform of input signal, assuming that initial condition to be 0. So if we will be look at this particular system, okay, so here what is the input to this system? This system for the figure A, r of t. So one can say r of t which will be represented as a random signal or any signal which will be input. So r of t, and this is g of t. G of t is nothing, there will be some gain of the system. Then there will be c of t. C of t is nothing, that is output of that system, or you can say control output of that system. So similarly here you can represent in the time domain. So figure 1 will be represented as a time domain. So all the time we have to represent output in terms of c of t, then gain g of t, and whatever that input, that is r of t. So if you'll be represent in that frequency domain, then all these terms will be represented as r of s, then g of s and c of s. And in the differential operator, if you want to define, then it can be x of t, then it will be gain of g of t, then it will be y of t. So these are some systems that it can be defined in terms of time domain, frequency domain, or in terms of differential operator domain. Okay. So there will be basic properties of transfer function, like zero initial conditions, then it is the same as the Laplace transform of its impulse response. Then stability can be easily find it from the transfer function. Then it can be applicable to any linear system. Advantages of transfer function, that poles and zero can be obtained from the transfer function. Then stability also can be find out from the transfer function. And that mathematical model which will be easily represented through this transfer function, and impulse response can be easily find out. So there will be some disadvantages will be there. It is not applicable for the initial condition if it will not be you can say that it cannot be as a negligible, and it gives no information about the actual structure of a physical system. So these are some disadvantages. Otherwise, that properties and advantages are more in case of transfer function. So particularly if we will be give one example to find how to find the transfer function for a particularly this electrical system, like here there will be some resistance, then there will be some inductor, then there will be some capacitor which will be there. Then overall the system which will be here, it will be written as some t time domain and v0, that is output voltage, which will be in the time domain. So if it will be converted into frequency domain, then this figure which will be which will be changed like this, that is whatever resistance which will be there, then inductor which will be ls, then this capacitor which will be represented as 1 by cs, and whatever that input voltage v of t, that will be represented as v of s, then v0 s output voltage. So if you'll be find, so this is some initial loops or input loop one can say. So if you'll be applying that kvl, then you can easily find this expression. Like here you can look at your R, L and this C, capacitor, resistor, inductor and capacitor all are in the series form. So we can easily find by using KVL. So this is our first equation. And if you are using the outer loop, or you can say this is loop 2. So if you are using loop 2, then we will be find this equation. So both the equation, if we will be find I of S. So from the second equation, I of S will be V0S by 1 by C of S. And by using that equation of I of S, then we can put in the first equation. Then you can easily find the V0S by V of S. So V0S means output voltage divided by input voltage. So that should be a second order system. You can look at here, this G of S is equal to 1 divided by LC square plus RCS plus 1. So from this we conclude that the transfer function is all the time it will be output voltage divided by input, but it is the Laplace transform of that function. Thank you.